Okay, so this is chapter 4.7, solving polynomial equations. And recall that in class we discussed the reason for solving polynomial equations, solving quadratic equations, is simply to find the values of x that satisfy the equation. And we also discussed that those solutions to the equations were actually called the roots or the zeros of the function and the x-intercepts of the graph. Now, although you're not completely aware of what the graphs of all of these equations or functions look like, eventually you will be. So this is a skill that you need to master, factoring and solving. Now, when I look at this problem right here, I can see that I have x minus 2, the quantity squared, times x minus 9. Well, this is already in factored form. And so I can say that x equals 2 and x equals 9. The only difference here is because of this exponent 2, we're going to say that this is a double root. So when we write our final answer, we'll say x equals 2, and we'll put a d period r period for double root as part of our solution. So this is the solution to the problem. These are very basic examples just to show you what the process is. Okay, let's look at another problem. Number 2, x squared minus 7x equals 18. Now here, when we're solving a polynomial equation, notice the first one was equal to 0. This needs to be equal to 0 also, so we'll end up subtracting 18 from both sides, rewriting this as x squared minus 7x minus 18 equals 0, and then factoring this quadratic trinomial. Okay? I'm looking for numbers that have a product of negative 18 and a sum of negative 7. And those numbers happen to be, and I'll put it in the big X like we've been doing it, negative 18, negative 7. So I get a negative 9 and a positive 2. So this becomes x minus 9, x plus 2 equals 0. So here, x equals 9, x equals negative 2. So our final answer is x is negative 2 and positive 9. Don't forget, these numbers that we're solving for are the solutions to the equation. They're the roots or zeros of the function, if I were to write it in function form. And they're also the x-intercepts of the graph. Okay, what you need to be concerned right now is just that they're the solutions, the roots, the zeros to the equation. Okay, let's look at a third problem. 3r squared, is equal to 10r plus 8. Now again, I want to have it equal to 0. I see that my r squared term is positive, so I'm going to bring this over and this over. And of course, when they cross the equal sign, they take the opposite sign. So this now becomes 3r squared minus 10r minus 8 equals 0. And now I am factoring to look for two numbers that have a product of negative 4 and a sum of negative 10, negative 24, and a sum of negative 10. And that would be negative 12 and positive 2. If I add these two numbers, I get negative 10. If I multiply, I get negative 24. So recall that this is the process where we break up the middle term. So I've got 3r squared minus 12r plus 2r minus 8 equals 0. And now I'm using my factor by grouping in order to continue factoring. GCF is 3r. I'm left with r minus 4. Here I can factor out a positive 2. Again, I'm left with r minus 4. My factors, this is my common factor. So I bring that down. Bring down the other numbers that aren't in parentheses, put it in parentheses. Those are my factors. Here, r is equal to 4. here, r is equal to negative 2/3. Now, if you need to see the long process, what I'm really doing is taking this factor, setting it equal to 0, and then solving for r. This is just a shortcut. R is equal to the opposite of this number over this number. So my two solutions are 4 and negative 2/3. I put it in my brackets, putting the smaller number first, the larger number second, and those are my solutions. In a nutshell, that's what this section of 4.7 is. You're taking various forms of polynomial equations, factoring them, and solving them. Okay? Of course, some of your homework problems will be a little bit more difficult. You may have to work a little bit harder, but this is the general process. Do well.